Okay, so we've got a confusion matrix and we've got a ROC curve as well as an AUC metric. Let's write this down actually. Let's communicate with ourselves. So now we've got a ROC curve, an AUC metric, and a confusion matrix. So we've got a ROC curve, an AUC metric, and a confusion matrix. Let's get a classification report as well as cross-validated, this is a key one here, cross-validated precision, recall, and F1 score. Beautiful. So, if we want a classification report, we've already imported the function there, so we can do it. We go print classification report. Now, classification report is going to give us the precision, recall, and F1 score, but let's see it first. Classification report, we can find it by passing it y_test and y_preds. Boom. This has given us everything that we need, right? Cross-validated precision, recall, F1 score. Well, not really. The reason being is because this classification report, it's been on y_preds, it's only being done on one set of test data. So we've got a classification report. It's been found by this, and we can tell that by coming up here, back to where we made predictions. So we only made predictions on the test data set. So if we come back, we only made predictions on here. So what we need to do is a cross-validation score of precision, recall, and F1, which is the values that we've got here, precision, recall, and F1. Now, you might be looking at this going, Daniel's telling me we need to cross-validate precision, recall, and F1. Still not exactly sure. I kind of forgot what's actually going on here, but that's okay. Let's get a refresh of what's happening. We've got precision. So precision indicates the proportion of positive identification, so aka the model predicts class 1, which has heart disease, which were actually correct. So a model which produces no false positives, right? So a false positive up here is false positive, predicted 1 when it's supposed to be 0. A model which predicts none of these has a precision of 1.0. All right, so that's precision. Now recall indicates the proportion of actual positives which were correctly classified. So a model which produces no false negatives has a recall of 1. So a model which produces no false negatives, so remember, false negative is where the model predicts 0. In a binary classification, predicts 0, where it should have predicted 1. So a model with 0 in this box will have a recall of 1, and a model with a precision of 1 will have a 0 in this box. So if our model was perfect, these would both be zeros, and our precision and recall would both be 1.0. And now F1 is a combination of precision and recall. So if our model was perfect and had precision and recall scores of 1.0, F1 would also be 1.0. Now support. Support is the number of samples each metric was calculated on. In our test data set, there are 29 samples with a value of 0 and 32 samples with a value of 1, so has heart disease. And now accuracy, we've seen that before. And macro average, this is short for average, is the average precision, recall, and F1 score between classes, so between these two. So the macro average doesn't take class imbalance into account. So if you have class imbalances, in our case we don't because we have relatively similar numbers or values here. So say for example this was 2 and this was 59, then you would have class imbalances. If you do have class imbalances, pay attention to the macro average. But for the weighted average, is the weighted average precision, recall, and F1 score. So weighted is the key here between classes. So weighted means each metric is calculated with respect to how many samples there are in each class. So aka this metric will favor the majority class, e.g. this will be a high value when one class outperforms another due to having more samples because that class has more samples and it will be given a higher weight. Whew, that was a bit of a mouthful, but you can look up this information in the classification report documentation. So classification report sklearn, you can also look up each of those metrics that we just covered individually, right? So if you wanted to find out more, actually, we want the user guide. There we go. This is going to tell you some information about the classification report. If you want to search for more, you go precision, recall F1, and you could look these up, macro average, weighted average, in the scikit-learn documentation. But remember, we just said before that these metrics here are only calculated, if we look at our cross-validation diagram, are only calculated on one test split. So what we want to do is recalculate these metrics, but with using cross-validation, which makes them a little bit more robust. So how could we do that? What we might do is wait till the next video. So spoiler alert, in the next video, we're going to calculate these metrics here using cross-validation.